Ever wondered what would actually happen if you fell into a black hole? From getting stretched like cosmic spaghetti to experiencing time differently, we're diving deep into this mind-bending cosmic journey. Buckle up, things are about to get weird. As you drift closer to a black hole's event horizon, that mysterious point of no return, things start getting seriously strange. First, you'd notice the stars behind you bunching up into a brilliant ring of light, while ahead of you lies an ever-growing circle of absolute darkness. Thanks to the black hole's immense gravitational pull, light itself begins to bend around you, creating what scientists call gravitational lensing. The closer you get, the more warped your view becomes. Imagine looking through a giant cosmic fishbowl. Your body would start feeling odd too. The difference in gravity between your head and feet becomes so strong that you'd begin to feel a gentle stretching sensation. Don't worry though. At this point it's still pretty mild. You're just getting a tiny preview of the famous spaghettification that awaits if you venture closer. Now comes the part that really makes black holes fascinating: spaghettification. As you fall deeper, the difference in gravitational force between your head and feet becomes dramatically stronger. Picture this. Your feet are being pulled down way more intensely than your head, creating what scientists call a tidal force. It's like cosmic taffy pulling, but with your body as the main ingredient. The process gets its fun pasta-inspired name because you'd literally get stretched out like a piece of spaghetti. Here's the wild part. While your body is being stretched vertically, it's also getting squeezed horizontally, kind of like pushing Play-Doh through a tiny hole. This isn't just some sci-fi concept, it's a real mathematical prediction based on Einstein's theory of general relativity. Pretty mind-bending stuff, right? Let's talk about one of the strangest effects of black holes: how they mess with time itself. Remember that scene in Interstellar where 1 hour on a planet equals 7 years on Earth? That's actually based on real science called time dilation. As you get closer to a black hole, gravity becomes so intense that time literally slows down compared to someone watching from far away. If you were falling toward a black hole with a really powerful telescope pointed back at Earth, you might see years or even decades flash by in what feels like minutes to you. It's like you're watching the universe on fast forward while you're stuck in slow motion. This isn't science fiction. It's a direct prediction from Einstein's theories that we've actually measured on a smaller scale right here on Earth using super precise atomic clocks. Now we're approaching the most famous part of a black hole, the event horizon. Think of it as nature's ultimate one-way street. Once you cross this boundary, even light itself can't escape, which is why we can't actually see what's inside a black hole. The math behind this is pretty wild. At the event horizon, space itself flows inward faster than the speed of light. It's like trying to swim up a river that's flowing down faster than you could ever possibly swim. Even if you fired up the most powerful rocket engines ever built, you'd still get pulled deeper into the black hole. This invisible boundary isn't actually a physical surface you can touch. It's more like a mathematical point of no return. And here's something that'll really bake your noodle. According to someone watching from far away, you'd appear to freeze in time as you approach this boundary. Let's explore what these intense gravitational forces would actually do to your body near a black hole. Imagine you're floating feet first toward it. The force on your feet would be dramatically stronger than the force on your head. To put this in perspective, if you were 6 feet tall and close enough to a stellar black hole, the gravitational pull on your feet might be millions of times stronger than on your head. This massive difference creates what scientists call tidal forces. Think of it like being pulled apart by 2 incredibly strong cosmic hands. Your body's not designed to handle these kinds of forces. Even the strongest materials we know would be torn apart. The atoms in your body would literally be pulled away from each other, starting with the weakest bonds first. It's a bit like stretching a rubber band until it snaps, except this stretching happens at the atomic level. Let's explore those final mind-bending moments as you cross the event horizon. Your view would be absolutely spectacular and terrifying. Imagine the entire universe's light condensing into an increasingly narrow band above you, forming a brilliant ring of blue shifted light. Below you, an expanding abyss of perfect darkness. As you cross the event horizon, that last glimpse of the outside universe would suddenly redshift and fade to black. But here's where it gets really weird. You wouldn't feel anything special at that exact moment. In fact, according to Einstein's equations, you'd float right through, completely unaware you've just crossed the point of no return. The real fireworks start moments later, as those tidal forces we talked about earlier become overwhelmingly intense. Your last conscious moments would be brief but extraordinary, a cosmic finale unlike anything else in the universe. Let's tackle the big question. Could future technology ever help us survive a black hole dive? While our current tech would be crushed like a soda can, some scientists have proposed wild theoretical solutions. Picture a spaceship with artificial gravity that perfectly counteracts the black hole's pull, or exotic materials that could withstand extreme tidal forces. One fascinating idea involves using quantum mechanical principles to create a shield against gravitational forces. But here's the catch. We'd need materials and energy sources way beyond anything we can currently imagine. We're talking about technology that could manipulate the very fabric of space-time itself. While these ideas make for great sci-fi stories, the harsh reality is that black holes remain nature's ultimate cosmic shredders. Now we're venturing into truly mysterious territory. What might exist beyond the event horizon? While we can't directly observe the interior of a black hole, Einstein's equations give us some fascinating possibilities. Some physicists suggest there could be an infinitely dense point called a singularity, where the laws of physics as we know them break down completely. Others propose more exotic ideas like wormholes that could theoretically connect different parts of space and time. There's even a mind-bending concept called the fuzzball theory, which suggests black holes might be more like tangles of cosmic strings rather than empty voids. While we can't prove any of these ideas yet, they show us how black holes continue to push the boundaries of our understanding of the universe. Let's look at what scientists have actually discovered about black holes in recent years. Remember that amazing first photo of a black hole from 2019? That orange glowing ring around M87's supermassive black hole showed us exactly what Einstein predicted nearly a century ago. We've also detected gravitational waves from black holes colliding. Imagine cosmic giants, each several times heavier than our Sun, spiraling together and sending ripples through space itself. Our Milky Way has its own monster black hole called Sagittarius A, which we've watched toss entire stars around like cosmic confetti. Scientists have even caught black holes in the act of shredding stars, creating what we call tidal disruption events. Basically, cosmic fireworks shows that can outshine entire galaxies. So what's the final destination for your cosmic spaghettified remains? Once you're stretched and squeezed through the black hole, your atoms essentially become part of the black hole's mass, increasing its size ever so slightly. But here's where things get truly bizarre. According to quantum mechanics, your information might not be completely lost. Some physicists suggest it could be preserved in what's called Hawking radiation, tiny particles that slowly leak out of black holes over incredibly long periods. Think of it like a cosmic recycling system, where your matter gets broken down to its most basic form and eventually re-released into the universe. Though you'd be completely unrecognizable in a way, you'd become one with the cosmos itself. Thanks for joining this mind-bending journey through black hole physics. If you enjoyed getting stretched, squeezed, and spaghettified, hit that like button and subscribe for more cosmic adventures. Share with your space-loving friends. Let's explore the universe together.